In this video I want to introduce a notation that's very common, and it causes a lot of confusion among students I found in the past. So I'm going to try to emphasize that really all we're doing is just I'm introducing a notation, and math notation is really, it's invented so that you don't have to write so much when you want to ask a question. That's what the notation does. It makes the question really concise. So keep that in mind as I go through this. So we're going to ease into it. I have a sequence here. It says find an explicit formula for the sequence. Well, that shouldn't be too hard. It looks like it's adding 2 every single time. It looks like it's a arithmetic. And we know that for an arithmetic, that any term is equal to the first term plus the common difference times n minus 1. We've seen that, and then that means that it's equal to 3 plus the common difference, which is 2, times n minus 1. So we can leave it like that. Sometimes people like to kind of clean it up a little bit. You don't have to do this, but some people like to kind of distribute that 2 there, and then rewrite this as a sub n equals 3 plus 2n minus 2, and then they might add the 3 and the minus 2, so you get 2n plus 1. So either one is fine. I might just use this. So either one of these 2 is fine. Actually, any of the 3. Okay. Part B asks us to find the sum of the first 6 terms. So that's not so hard, right? You're just going to add up the first 6 terms. So 3 plus 5 plus 7 plus 9 plus 11. One more, right? Plus 13. And it looks like if you do that on the calculator, you get 3 plus 5 plus 7 plus 9 plus 11 plus 13. We get 48. Okay, so far nothing too interesting has happened. Now, I want to draw your attention to question B. If I don't want to write this question as it is, there's a concise way of writing it. And that's using what's called sigma notation. So sigma, for those who don't know, is this Greek letter. It's like a Greek S, okay, and it stands for sum. I shouldn't say equals, it means sum. Okay, so sigma notation is just, it's used so that the reader knows we're expecting to sum up a bunch of terms here. So what I'm going to write down is exactly the same as asking question B. So this here, the sigma symbol, means I want to sum up. Now to get across the idea that I want to sum up the first 6 terms, what I'm going to do is I'm going to say my terms start at 1, so the starting term goes down here at the bottom with a little n equals. N goes from 1, and then where you stop is up here. So up to the 6th term. Now, what has to go in here is the rule. In other words, what is the explicit formula for my arithmetic sequence? We found that it was 2n plus 1. 2n plus 1. So this here asks the exact same question as this. Find the sum of the first 6 terms is all captured in this notation here. Now, let's make a few notes just to make it really clear. So in regular sigma notation, we always put the rule here in front. This is our starting n value, or our term number, that we're going to plug in, and this is our ending term number. So let's pretend I had like a Men in Black, one of those Men in Black tasers, and I held it in front of your face, and you just completely forgot that we did question B. If I then asked you to look down here and evaluate this expression here. So let's just say I said evaluate. Evaluate that. This is how it works. You say, okay, this is equal to, Now I'm going to start by plugging in my 1 into my rule. When I plug in a 1 into my rule, I get 2n plus 1, which is 3. Now I put a plus. Why do I put a plus? Well, that's what the sigma is telling us. The sigma notation is telling us to put pluses in between each term that we get out. Now what's after term 1? Term 2. So plug in a 2 into n, in for n, and you get 2 times 2, which is 4 plus 1 is 5. Plug in 3, you get 2 times 3 plus 1, which is 7, plus. Plug in a 4, you get 2 times 4 plus 1 is a 9. Plug in 5, you get 5 times 2 plus 1 is 11. And then plug in 6, you get 2 times 6 plus 1 is 13. And now I stop. That's what this 6 up here means. It means stop after plugging in the first, plugging in 6. And so that is how sigma notation works. So less and less I'm going to be asking questions like phrase like this, and more I'm just going to ask that question by saying evaluate this expression here, this sigma notation expression. Alright, so I'm going to flip the page to let you see a few examples. You should pause it and try them on your own, and then I'll just reveal the answers. Alright, so I would pause the video, try this one on your own. Alright, I'm going to assume you did that. So here it's just plug in 1 squared, plug in 2 plus 2 squared, plug in 3, plug in 4, then plug in 5, and we stop. So this is 1 plus 4 plus 9 plus 16 plus 25. All that ends up equaling 55. And for this one here, notice this time I'm starting by plugging in 3. So I'm plugging in the third term. I'm plugging in 3 into our rule. So 3 times 2 plus 1 is 7 plus 9 plus 11 plus 13 plus 15 plus 17. So again, this was plugging in 3, 4, 5, 6, 7, and 8. And so I stop here and I add them up. And I get my answer of 72. Alright, so there's sigma notation. So just get familiar with it and don't let it scare you.